This is GMAT 41. You are welcome to our statistics class. In this video, we now turn our attention to another measure of position, also known as fractiles. Fractiles in the sense that they represent the fraction of certain values as given in the whole distribution. Although somehow similar to measure of central tendency, but not exactly the same, because these measures of position, they are used to locate the position of any observation in the given distribution. But of course, you know that measures of location are used to locate the center of the distribution. But for measures of position, they locate the position of a certain data as seen in that given distribution. Measures of position are statistical measures based on their position in the distribution. Of course, they serve as numerical characteristics of a given frequency distribution. Why is it important that we study measures of position? These measures are important because some measures of dispersion, because we're going to study measures of dispersion after measures of position. Some of these measures of dispersion depend on measure of position. For example, under measures of dispersion, where we study things like the mean deviation, you talk about the interquartile range, the interpercentile range, alright? Some of this range, they depend on these measures of position. And that is why it's important for us to study fractiles, measures of position. There are three most important of them. We have the quartiles, we have the deciles, we have the percentiles. Quartile, from quartile. Alright? Quartiles are simply those fractiles that divide the whole distribution into 4 equal parts. And the fact that they divide the distribution into 4 equal parts means that we have 3 quartiles. Alright? So the number of parts they divide the distribution. For us to know how many of these fractiles we have, it will be 1 less than the number of division that they create. So if you're talking about quartiles, it divides the distribution into 4 equal parts, hence we have 3 quartiles. These 3 quartiles include the lower quartile, also known as the first quartile. We use Q subscript 1 to represent it. We have the middle quartile, also known as the second quartile. We use Q2 for it. It's very important for us to know the second quartile is equal to the median. Alright? Then we have the upper quartile, also known as the third quartile, Q subscript 3. For the lower quartile, also known as first quartile, it is used to locate all distributions that fall below 25% of the entire distribution. While the second quartile is used to locate all values below 50% of the distribution. Then of course, we talk about the upper quartile used to locate all distribution above 75% of the given distribution. Next, we want to look at the deciles, but before then, let me quickly state, because of their use under measures of dispersion, Q1 and Q3 are very, very important, because we use them to determine the quartile deviation under measures of dispersion. The deciles. Deciles are fractiles that divide the distribution into 10 equal parts. Hence, how many deciles do you think we'll have? There are 9 deciles. We use these subscripts to represent it. So we have D1, D2, D3 down to D9. Then we now talk about the percentiles. But once again, before we move on, I want to state that D5, that is the 5th decile, represents the median. Because that's the middle of that distribution. Now we'll talk about the percentiles, which are fractiles that divide the whole distribution into 100 equal parts. And hence there are 99 percentiles from P1 to P99. P50, that is the 50th percentile, represents the median of the distribution. Because of the importance of these measures of position in measures of dispersion, for percentiles, we are going to be interested in P10 and P90. Because these 2 percentiles are used to obtain our interpercentile range under measures of dispersion. In the next video, we are going to see the general formula for fractiles and then take some questions under them. We now want to see how we can estimate the fractiles. Is that okay? Then quickly before I go into that, I want to state that if you've watched our video on how to calculate the median or how to estimate the median from the cumulative frequency curve A, then you're good to go for how to estimate your fractiles, measures of position. Why? Because they are exactly the same. The only difference is that the median in that case is now replaced with either quartile or decile or percentile, as the case might be. Let us find out. Just like you can obtain the median either graphically or by calculation, in the same way the fractiles can either be obtained by formula-based calculation or graphically from cumulative frequency curve OD. Now let us look at the three of the fractiles now. Suppose you want to get your quartile. This is the formula we use for quartile. It's going to be Q subscript n representing the nth quartile value. Okay, it could be Q1 you want to get, or Q2 or Q3. So in that case it will be Q subscript n equal to the lower class boundary of the nth quartile class plus open bracket n over 4. We are dividing by 4 now because in this case we are dealing with quartiles, which divides the distribution into how many equal parts? 4. So the n here, as it depends on the particular quartile you want to get. If it is the first quartile, it will be 1 over 4. If it is the second quartile, it will be 2 over 4. If it is the third quartile, it will be what? 3 over 4. Then times summation of all the frequencies minus cumulative frequency of the pre-nth quartile class divided by frequency of the nth quartile class, close your bracket, and multiply by the class width of the nth quartile class. While reading this formula, I've already stated the meaning of all these parameters used. You can also go through them here and see the meaning of those parameters, because the decile and the percentile still uses the same parameter. The only difference is that the Qn now is replaced with Dn and Pn. If you look at this formula, take your mind back to what you saw for median calculation. You would see that it's almost the same. The only difference is that we used ME, that's subscript ME for median in that case. Is that okay? Now let us look at the decile. To obtain the decile, it's still the same thing. Come to this formula, replace all Qn's with what? Dn. Then again, please watch around here, okay? This is n over 10. Why? Because decile divides the distribution into how many equal parts? 10 equal parts. So if you want to calculate a particular decile, let's assume the 5th decile is going to be, in place of this n, you put 5 over 10. Is that okay? The formula is essentially the same. Let's read it and see. This is to obtain the nth decile, that's any particular decile, is equal to lower class boundary of the nth decile plus open bracket n divided by 10. That's that particular position of decile I want to get, divided by what? 10 times summation of frequencies minus cumulative frequency of the pre-nth decile class divided by the frequency of what? The nth decile class. Close your brackets and multiply by what? The class width of the nth decile class. Percentile, still similar. In place of all the dn's and or qn, you now replace it with what? Pn. So to obtain the nth percentile, that's a particular percentile value from that 1 to 99 percentile. To obtain any one of them is equal to the lower class boundary of the nth percentile class plus, this time around now, n divided by what? 100, because percentile divides the distribution into 100 equal parts, times summation of frequencies minus cumulative frequency of the pre-nth percentile class divided by frequency of what? The nth percentile, and then close the bracket and multiply by class width of the nth percentile class. So these are the formula that you need to know. But as an advice, you just need to memorize only one of the formula, and that it's going to guide you for the others. Yes, it's going to guide you for the others. Note, in decile and percentile, all parameters used are the same with the quartiles, but subscripts change towards D and P. That's why I really didn't define these parameters here, because they are exactly the same as the ones defined for quartiles. The only thing is the subscripts have to be changed to the particular fractile that you're dealing with. In the next video, we shall pick questions and then apply these formulas. In this video, we are going to see how we can apply the formulas for quartile, deciles, and percentile in obtaining the values of certain fractiles. On the board here we have this question: using the scores of the sample of 45 randomly selected students in the statistic examination, reference was made to table 2A. Calculate I, Q1 and Q3, that is the lower and upper quartiles, first and third quartile. Then I calculate the 5th decile, that's D5. Then I calculate the 10th percentile, that's P10, and the 90th percentile, that is P90. Now let's see how we can solve this problem. Okay, the first we have to obtain Q1 and Q3. Q1 and Q3. Now it's very important for us to recall the quartile formula before we can proceed to obtain Q1 and Q3. So I'm going to write recall. We know that the quartile formula is giving us Qn. Alright, that is the particular quartile you are looking for, equal to the lower class boundary of the nth quartile class plus open brackets n over 4 times summation of the frequencies minus the cumulative frequency of the pre-nth quartile class, okay, which is this. Then all divided by the frequency of the nth quartile class. We're going to multiply it by the class width of the nth quartile class. So this is the formula we're going to use. Now for us to proceed to calculate, first we're going to find Q1. It means we are going to determine the class in this table that is called the first quartile class. Is that okay? This table is an extract from table 2A as part of our solution. Since reference was made to table 2A, it means that you should have obtained that table 2A first. Is that okay? And now from that table, the data we need to be able to solve our problem and this question include the score, the frequency, the class boundary and cumulative frequency column. So we had to extract it from table 2A to show as part of our solution. So let us obtain our Q1 class, okay? So Q1 class, let us obtain it. To obtain our Q1 class, we are going to determine the value of 1 over 4 summation F. Let's obtain it. So from n over 4 summation F, it implies we're going to have 1 over 4 summation F. And of course, summation F is 45, okay? All the frequencies added together. So let us see what it's going to give to us. That's going to be 45 divided by 4. From here, it's 11.25. Is that okay? Now, get your pen, get your book. Let's see what we have to do with this 11.25. Remember, I want to determine the Q1 class, okay? That's the first quartile class. We shall now go to the cumulative frequency column and then see if we can get 11.25. If we obtain or see 11.25 in the cumulative frequency column, it means that that column is our first quartile class that we're going to use in calculating Q1. Alright, so let's go. Do we have 11.25 here? No, it's not there. Therefore, we're going to take the cumulative frequency that is just greater than 11.25. Now, 11.25 will be seen between 8 and 16, is that not so? So between these two, the cumulative frequency just greater than 11.25 is this of 16. Therefore, this is going to be our Q1 class. We're going to identify that. That's going to be our Q1 class. Let me write that here. Q1, is that okay? That's the Q1 class. We are now set to determine the value of Q1. Alright, so I'm going to substitute that. To get the value of Q1, we're going to use the formula. So we have Q1 equal to xQ1 plus open bracket 1 over 4 summation F minus cumulative frequency. That's going to be Q1 negative 1. That is of the pre-quartile class, pre-first quartile class. Is that okay? That's going to be divided by summation. Alright, now that is a frequency of the first quartile class, then multiplied by the class width of the first quartile class. Now, having obtained the first quartile class, we should get the value of xQ1 and the rest of them. So xQ1, which is the lower class boundary of the first quartile class, that is 59.5, right? So we're going to write 59.5, and then we shall obtain our cumulative frequency of the pre-first quartile class. So CF Q11, Alright, so we'll come over here. This is our first quartile class. So the class before it is 8. So that's the cumulative frequency of the class before the Q1 class. Then we need the frequency of the first quartile class, so FQ1. The frequency is what? 8. And of course, our class width, CQ1, you can find out that it's equal to 5. You can do upper class boundary minus lower class boundary. Now let us substitute into the Q1 formula and then see what we're going to get. In place of lower class boundary of the first quartile class, we're going to put 59.5 because that's the lower class boundary, then plus open bracket. Did you recall that summation f divided by 4, we obtain it 1 over 4 times 45 to the 11.25. So I'm going to substitute that 11.25 for 1 over 4 times summation of frequency. Then subtract this cumulative frequency of the pre-first quartile class, and that cumulative frequency of the pre-first quartile class is 8. So I'm going to divide it by the frequency of the first quartile class, which of course happens to be 8 as well too. Multiply that by the class width. Now let us see what this is going to give to us. This is 59.5 plus. We shall obtain everything here first, starting with the bracket. So let's do that. We have 11.25 minus 8. Okay, it's giving me 3.25 here. I'm going to divide it by 8. That is 0.40625. Now I will multiply all that term in brackets by 5. And it's giving me 2.03125. So you're going to have 2.03. Let me approximate that. Therefore, we notice that the first quartile for this problem has the value of 2.03. We're going to add 59.5 to it. And this is 61.53%. So you see, 61.53% is the value of what? Q1. That is the lower quartile. We're going to take a break. When we come back, we'll calculate for Q3. Now, we are going to look at how to obtain Q3. That is the upper quartile or third quartile. We're going to follow the same procedure that we use in obtaining Q1 before the break. So, to get Q3, the Q3 class, then we're going to obtain n over 4 summation f. With this n over 4 summation f, it will help us to locate the Q3 class from here. Is that okay? So that's going to be, we are looking for Q3, so n is equal to 3. So 3 over 4 times 45, which is our summation f. If we do that, let's see, you can press your calculator. 3 over 4 times 45, this is 33.75, okay? So we will now move on to the cumulative frequency column and then locate 33.75 if it is there. So I'm going to ask, in the cumulative frequency column, do we have 33.75? I don't think so. But of course, you see that 33.75 will be between this 33 and 39, right? So we're going to pick the higher cumulative frequency, just greater than 33.75, which happens to be 39 here. So this is our Q3 row or class. Let me indicate it, Q3. So from there, we can now define all our Q3 parameters. You see that here, the formula for Q3 will now become Q3 equal to X Q3. So I'm writing the formula from here now, plus open bracket n over 4, where n is what? 3. So it's going to be 3 over 4 times summation of frequency minus cumulative frequency of the pre-third quartile class. That is the class before the third quartile class. So that's going to be Q3 negative 1 divided by our frequency of the third quartile class. So FQ3, then CQ3. That's the class width of the third quartile class. So with this, having identified the third quartile class, we can now bring out the values of the parameters. So SQ3 from the table there, lower class boundary of the third quartile class is 74.5. Then the cumulative frequency of the class before the third quartile class, that's let's look at it, is 33, okay? And then the frequency of the third quartile class, let's trace and see, that is 6. Of course, our class width of the third quartile class is still 5. So we can now substitute to obtain Q3. So lower class boundary of the third quartile class is 74.5. So we substitute plus open bracket 3 over 4 times summation F. We've already gotten it to be 33.75. So I will substitute directly minus the cumulative frequency of the class before the third quartile class. That cumulative frequency is 33. And then divided by frequency of the third quartile class, which we obtained as 6, times the class width, which is 5. So Q3 is going to be 74.5 plus. Now let us obtain the value of this bracket times the 5 out there, so we can see what we're going to get. So 33.5 minus 33, it's giving me 0.75. I'm going to divide it by 6. So divided by 6, I have 0.125. So the whole bracket here is 0.125. I will multiply it by a class width 5, which gives me 0.625. Now, the third quartile class has the value of Q3. Is that okay? That's the third quartile value is given as 0.625 added to the lower class boundary of that third quartile class, 75. So I have 75.13%. So this gives us the Q3 value for this student score.